Welcome to another Azure Guy video, where hands-on learning is priority one. I'm an Azure Administrator, Azure Security Engineer, as well as an Azure Solutions Architect. Welcome and thanks for watching this video. This video is the first video in a series which will help you learn Azure and pass the admin exam as well as the architect exam. The video series will be about 20-30% slides and the rest hands-on activity. There will also be sample questions and sample quizzes in the series. So let's get started. In this video, we'll start by learning about VMs. Availability sets provide for redundancy and availability. Availability sets should have two or more VMs. This will provide a 99.95 Azure SLA. It might be wise to note availability sets do not protect your applications from OS or application type failures. They do limit the potential physical hardware failures, network outages, and power interruptions. There is no cost for the availability set. You only pay for each VM instance. You must install the VM into the availability set at time of creation. So what is an update domain good for? It allows Azure to group VMs and underlying physical hardware that can be rebooted at the same time. Each virtual machine in your availability set is assigned an update domain and fault domain. By default, you get 5 update domains, but can be increased to 20. For example, if you have 6 VMs in the availability set, which update domain is a 6th VM assigned? Remember, by default, there are 5. The 6th VM is placed in the same update domain as the first. If there was a 7th VM, it would be placed in the same update domain as the second. So that is update domains. Let's learn something about fault domains. Fault domains define the group of VMs that share a common power source and network switch. By default, the VMs configured within our availability set are separated across up to 3 fault domains. So to recap all of that, imagine we have these rectangles are racks. So we have rack 0, rack 1, and rack 2. There are 3 separate power sources. One power source goes to rack 0, one goes to rack 1, and one goes to rack 2. So if we lost power or network switch in any of these individual racks, rack 1 and rack 2 would still have full power. If you look at the update domains, if we wanted to reboot for maintenance update domain 0, we still have update domain 1 and 2 working. Next topic, availability zones. While availability sets protects your applications and data from a hardware failure in data center, availability zones go one step farther and protects your applications and data from data center failures. Availability zones are unique physical locations within an Azure region. Each zone is made up of one or more data centers equipped with independent power, cooling, and networking. There are at least 3 separate zones in all enabled regions. The physical distance of availability zones within the region is what protects your applications and data from data center failures. Your applications and data are replicated across availability zones to protect from single points of failure. If you recall, availability sets provide an SLA of 99.95. Availability zones provide an SLA of 99.99. Proximity groups are a fairly new feature. They are used with VMs, availability sets, or virtual machine scale sets. Why does this feature exist? Placing VMs in a single region reduces the physical distance between the instances. Placing them within a single availability zone will also bring them physically closer together. However, as Azure footprint grows, a single availability zone may span multiple data centers, which may result in network latency, hence proximity placement groups, to get VMs as close as possible. You can move an existing resource into a proximity placement group. However, when doing so, Stop the asset first, since it will be deployed potentially into a different data center in the region. Some general tips. Use proximity placement together with accelerant networking. Deploy all VM sizes in a single template. This will prevent landing on hardware that does not support all the VM SKUs and sizes. If latency is your first priority, put VMs in a proximity placement group and the entire solution in availability zone. If resiliency is your top priority, spread your instances across scale sets. You may have heard the metaphor cattle versus pets, comparing old style server computer design to more current. The idea is your VMs just come and go. This is where scale sets come into play. One example is Xbox Live Gaming Service. This service will bring up and shut down gaming servers for popular games. For example, whenever you start a new multiplayer Titanfall match, there's an Azure virtual machine being created to host it. When the game is over, the VM goes away. Scale set can auto scale, meaning Azure can add and remove virtual machines depending on some monitored parameter. You can also add and remove instances either through the portal or with PowerShell. Now let's test how much you learned by some review questions. Now review questions are not the same as sample test questions. Review questions are generally shorter and to some degree easier, but do cover core concepts. So good luck.